Chapter 14, Chapter 14, almost done with the book, almost done with the book. Chapter 14, more about cargo and crates.io. Close this. So far, we've used only the basic features of cargo to build, run, and test our code. But it can do a lot more. In this chapter, we'll discuss some of its other, more advanced features to show you how to do the following. 1. Customize your build through release profiles. 2. Publish libraries on crates.io. 3. Organize large projects with workspaces. 4. Install binaries from crates.io. 5. Extend cargo using custom commands. I'm excited. Cargo can do even more than what we cover in this chapter. So for a full explanation of all its features, see its documentation. Okay, I keep that noted, but yeah, let's continue onward. Customizing builds with release profiles. Okay. In Rust, release profiles are predefined and customizable profiles with different configurations that allow a programmer to have more control over various options for compiling code. Each profile is configured independently of the others. Okay. So we're gonna have different profiles where you can put different configurations for your builds. I like. Cargo has two main profiles. The dev profile Cargo uses when you run cargo build, and the release profile Cargo uses when you run cargo build release. The dev profile is defined with good defaults for development, and the release profile has good defaults for release builds. So what this tells me is that by default there's already two profiles, and we've only used one because we're just building things. We've been using the dev profile every time we ran cargo build. But there is a release flag that you can put on the build that uses the release profile, which has good defaults for releasing. I'm not sure what these defaults are, but hopefully I'll get to that. These profile names might be familiar from the output of your builds. This is very true. Right here, in every build, there is a finished dev. I guess the profile's been here the entire time. Noted. The dev and release shown in this build output indicates that the compiler is using different profiles. Cargo has default settings for each of the profiles that apply when there aren't any profiles.star sections in the project's cargo.toml file. By adding a profile.star sections for any profile you want to customize, you can override any subset of the default settings. For example, here are the default values for the opt level settings for the dev and release profiles. Really quickly. So what they're saying here is that our profiles are defined in our cargo.toml file, and the section is seemingly, the way they write it here, profile dot and then the name of the profile you want to use. And even for the default ones, which are dev and release, we can override any of their default settings by just doing a profile in our cargo file, in our toml file, and then putting the setting that we actually want. And presumably we can also put other settings there too, like profile.staging, and then have a settings for your staging listing out. So here they have the example of the toml file, and they have op level. I'm not sure what op level means. 0, 3. And here they explain it. Good. The op level setting controls the number of optimizations Rust will apply to your code. With a range of 0 to 3, applying more optimizations extends compiling time. So if you're in development and compiling your code often, you'll want faster compiling even if the resulting code runs slower. Makes sense? So let me just summarize that for this part, because that part came to a perfect ending. So the op levels, which we were wondering about earlier, are the levels of optimization that Rust will apply when compiling. And one of the reasons why the defaults are different for dev and release is because for dev, you want to be able to develop faster, which means you want your compile time to be less. And if your compile time is less, that means proportionally you're applying not as many optimizations, because the more optimizations you apply to the compiling process, the longer it's going to take. So that's why dev is 0. And then release, well, they want your code to run faster. You're not necessarily rebuilding it often. You're building it once and then hoping it stays good. So you up the level of optimizations, one, because you want it to run faster, and no, not just because you want it to run faster. What they stated here is that if you apply more optimizations, your code will run faster. They said the opposite, but you know, if you put a negative to a statement, your code will run faster with more optimizations. That's the reason the default op level for dev is 0. When you are ready to release your code, it's best to spend more time compiling. You'll only compile in release mode once, but you'll run the compiled program many times. So release mode trades longer compile time for code that runs faster. That is why the default op level for release profile is 3. Which, yeah, I just went over that. Makes complete sense. You're good. You can override any default setting by adding a different value for it in the cargo.toml file. For example, if we want to use the optimization level 1 in the development profile, we can add these 2 lines to our project's cargo.toml file. And then here's the example, which I went over earlier. That makes sense. Yeah, just put the setting and then put the value that you want to have, and it'll override the default. This code overrides the default setting of 0. Now, when we run cargo build, cargo will use the default for the dev profile plus our customizations to op level, because we set op level to 1. Cargo will apply more optimizations than the default, but not as many as in a release build. For the full list of configuration options and defaults for each profile, see cargo's documentation. We've reached the end of this video. If you like it, subscribe. Outside of that, peace.